Now, basic metrics. We'll be talking about defects versus defective. We'll be talking about units. We'll be talking about opportunity. We'll be talking about DPU, which is defects per unit. We'll be talking about DPO, which is defects per opportunity. And we'll be talking about DPMO, which is defects per million opportunity. Okay. How many of you are excited to learn all this? Type ETL in the chat box. And today is going to be amazing session. Okay, what do you see on the screen? What do you see on the screen? Come on. What do you see on the screen? A car. Do you see only a car or something else? With errors? Fantastic. Okay. So now this car has got this warning symbols, which means there is a defect on the headlight. There is a defect on the door. How many defects are there in this car? Just type 2 in the chat box. There are 2 defects. No, the top red one is not a defect. Okay, there are 2 defects in this car. Okay, fine. Now, defect is defect from defective. The car is defective. It has got 2 defects. If this is clear, type SC, super clear in the chat box. This has to be 100% clear before we proceed further. The car is defective. It has got 2 defects. And I'll go slowly and steadily because these concepts are very important. I don't rush through these sessions. I take the session in my own pace, my own style, in my own decision. Now, if you see, how many units are there? How many cars are there? Okay, 9 cars are there. These are all called units. Please write in your notebook, units. These are all, how many units are there? 9 units are there. Now, how many defects are there in this car, in the first car? How many defects are there? Now, count the total number of defects. Okay, if you see here 2, here 1, here 2, here 1, etc., etc. So these are all called defects. The 9 units can have even 15 defects. Do you agree? It can have even 15 defects. Okay, because each car can have 2 to 3 defects. But there can be, if there are 9 units, there can be only 9 defective cars. You cannot have 15 defective cars. I just wanted to explain to you about these defects and defectives. All right. Now, defects and defectives. Defects refer to individual flaws or imperfections in a product or service, whereas defective refers to the units or items that contain in 1 or more defects. This is clear. Type SC, super clear in the chat box. All right. This is the first difference. The second is it focuses on the specific issues or problems found in individual units, whereas it focuses on the total number of units or items that do not meet the quality standards. Okay, that is a defective. Now, if the second one is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super clear. All right. Now, defects can be classified as minor defect or major defect, depending upon the impact they have on product functionality or appearance, whereas defectives does not have degrees of severity, since it simply represents the unit as defective. If this is super clear, type SC in the chat box. Super fantastic. All right. Now, a defect is an attribute or a characteristic of a single item that does not conform to the desired specification for a single item, whereas defective is the entire unit or item that failed to meet the quality standards. All right. So if this is also clear, please give me a 9 or 10 on a scale of 1 to 10 if so far if it is clear. Because these concepts I want to go into your blood and nerves. Okay, most of you have typed 8, 9 or 10. Fantastic. Those who have typed the lesser number, if you've not understood, please go through these recordings. Okay. You know, probably you're not experienced or probably you didn't focus on this. Probably you need 2 or 3 more rounds of understanding. That's fine. That's fine. Not everybody is at the same level of understanding. Now, A scratch on the surface of a phone in a shirt if the button is missing. On an electronic device, some component is faulty. That means those are all defects. Whereas if there is a batch of shirt with incorrect stitching, if the phones are shipped with every component, every phone having a malfunctioning on the touch screen and some electronic parts which are not functioning, these are all called defective. So if the examples are clear, type CC crystal clear in the chat box. All right, now we will go to DPMO and sigma value details. Okay, now in order to go through what is DPMO and sigma value, all of you please take good notes. We need to know three things: UOD, okay, or DOU, whatever it is. Type DOU or UOD in the chat box. DOU, whatever. Defect, opportunities, and units. Defects, opportunities, and units. Okay, very simple concept, and I'll make it much simpler. Total opportunity. Total opportunity. What is TOP? What is DPU? Defects per unit. What is DPO? Defects per opportunity. And what is defect per million opportunity? Okay, I'll make this so clear that even in your dreams, if somebody wakes you up at your deep sleep and say, what is DPU, DPMO, you will be able to answer. How many of you are excited? Just type XITD. Because energy is important in learning, and excitement will give you that energy for learning. I'll tell you, in this life, if you learn something, you will secrete those happiness chemicals of that satisfaction, so that you will feel, wow, what a time well spent. How many of you agree with me? Okay, so learn with a lot of excitement, and that's my purpose of teaching. And finally, what is the capability, your capability, that will be increased? Okay, sigma capability. Now, what is an opportunity? Opportunity is nothing but, suppose if this is a phone and this is the cover of the phone. Okay, this is the cover of the phone. Let me take this cover of the phone. What dimensions are important in that? What are the key dimensions which are important in this cover? Let's say, just for sake of simplicity, length, breadth, and height for packaging, LBW. Okay, LBW. So if length can go wrong, breadth can go wrong, and the depth can go wrong. Length, width, and depth. Okay, LWD. Length, width, and depth. It can go wrong. So far, if it is clear, type clear in the chat box. Okay. Now, since these three can go wrong, these are all called what can go wrong, and important to the product is called as an opportunity for defect. There is length is one opportunity which can go as a defect. Width is one opportunity which can go as a defect, and depth is one opportunity that can go as a defect. If this is clear, please give me a 9 or 10. 3 opportunities in this. So my question is, if there are 10 such covers and 3 opportunities in each of these covers, how much is the total opportunity? Okay, all of you type number of units, which is 10, into 3 opportunities, which is 30 opportunity. Please type 10 into 3. Because I wanted to understand 10 is units and O is total number of opportunities. Because later on, I will say defects per opportunity and defects per units. There are only 2 things: total opportunity and total units, and defects per unit, defects per opportunity. Super clear. So far, if you are finding it interesting, useful, valuable, fantastic, awesome, put it in the chat box. Okay, I wanted a lot of interest in you, excitement in you. All right. Now, this is very simple. Defects per unit. You understood what is a defect. You saw 9 cars there, and there can be 5 defects. All the 5 defects can be in one car, or 5 defects can be in 5 cars. So 5 by 9 defects per unit. And defects per opportunity. If every car has got 3 opportunities, and there are 9 cars, 9 threes are 27 opportunity, and 5 defects are there, 5 divided by 27. We'll see some examples so that you are very clear. And then defects per opportunity into 10 power 6. When you convert it into million, it is defect per million opportunity. So far, if it is clear, give me a 9 or 10 if it is super clear. With examples, you will become very, very clear. But as of now, I wanted to check with you if you're clear in this. Okay, I'm going to go deeper into. If the customer is asking, somebody is asking, if there are 9 cases, if customer is asking you to check some 10 different specifications, and each specification important to the customer means each of them is an opportunity to create a defect. And finally, we'll find out sigma capability. Very easy. Sigma capability is very easy because you just see one table and find out. Once you calculate DPMO, you can find out from the table. Now, let me take an example of a service industry. Let's say that you are in purchase department, and all of them, in every business, they make invoices. So I'm taking the invoice example. Now, units means what? A unit is an item that is produced and is liable for measurement or evaluation against a set criteria. Don't complicate. Unit means there's one. Invoice is 1 unit. One invoice is 1 unit. Okay? Simple. Now, opportunity means in an invoice, what all can go wrong in an invoice? What all can go wrong in an invoice? Please type in the chat box. Let's see. What all can go. If you have seen anybody who has made invoice, what all can go wrong? The date, the values, the price, the item, the quantity, the vendor, okay, vehicle number, customer number, all your experiences are coming out here. In invoice, currency, price, details, okay. A lot of things can go wrong. So for the sake of our understanding, let's say name and address, one opportunity for defect. This can go as a defect. This can create a defect. That means that's one opportunity for defect. Contact details can go wrong. Second opportunity for defect. Invoice number can go wrong. Item description, quantity, cost per unit, bank account number, etc. Let's, for our example, take there are 8 opportunity for defect. Okay. If it is clear, type SC, super clear in the chat box. Now my question is, the areas in which defects could be produced is called as an opportunity by definition, and the chances in a unit to have a defect. That's what we had defined it. Now let's see a lot of invoices we are checking. We are checking a lot of invoices, and finally we found a discrepancy. And how many defects are there? 10 defects are there. So all of you type, all of you write in your notebook, defect, 10 defects are there. Number of defects, 10. Okay. Now suppose, let's say there are 1,200 invoices. Let's say there are 1,200 invoices, all of you, and there are 10 defects, and there are 1,200 units, invoices. So what is DPU, defects per unit? Please put it in the chat box. 10 divided by 1,200. What is the value that it comes to? 0.0083. So if DPU is clear, give me a 9 or 10 or crystal clear or super clear, whatever it is. All right. Thank you very much. And now the question. I'll ask some question also. So DPU measures defective parts in manufacturing process, defective units in service delivery process, defective products in production line, defects in single unit of output. So what's the correct answer in this? Let's see the correct answer. Defects in single unit of output. Right. Now, total opportunities. How many opportunities were there in the invoice? Let's see who remembers that. How many opportunities were there in the invoice? No, eight. Please type 8 in the chat box, okay? 8 places where it can be defective, okay? Now, total number of opportunities. If there are 1,200 units, that is 1,200 invoices, how many opportunities are there? Let's quickly see the math. Excellent. 8 into 1,200, which is 9,600. Okay. The total number of chances of all units into this, and 1,200 units were there. And now you have 9,600 opportunities. What is, and you know 10 defects are there. What is defect per opportunity? DPO. How much is defect per opportunity? How much is defect per opportunity? 10 divided by 9,600. So defects per opportunity is nothing but 10 divided by 9. Simple, very, very simple. And multiply this by 1 million, which is 10 power 6. It is defects per million opportunity. Multiply this by 1 million and tell me the answer. 1 million is 10 lakhs, okay? 10 power 6. Excellent. So 1041. Fantastic, okay? Now the question and answer here is, what does DPMO stand for in the context of process improvement? Defective products manufacturing operation, defects per million opportunities, demand production management organization, delays and problem mitigation process. Very simple answer, right? Very simple answer. Of course, all of you will give the correct answer. So the correct answer is defects per million opportunities. Okay. Now defects per million opportunities, as you rightly said, this is 10 divided by 9,600 into 10 power 6, which is 1041.47. Okay, great. All right, now the question here is, which metric is commonly used to assess the performance of a process in terms of defects per million opportunities? It's very, very straightforward because we are talking the same subject. So you can type the answer. Naturally, it is C. Okay. So DPMO. Fantastic. Okay. So some more questions on DPMO because it's a subject. What does DPMO help measure in a process? The percentage of defects in the final product, the number of opportunity for defects in a process, the number of defects found in the sample, costs associated with the defect. Little tricky question, but put your mind, choose the best answer. All right, let's see what's the right answer. Number of opportunities for defects in a process. Okay, number of opportunities for defects. Now, sigma value is very simple. By definition, it is a number which tells you how much you are able to meet within the specification limits. For example, we said that the DPMO is 1041.67. The sigma level can easily be calculated from a table. I'll share with you the table, and from the table you can see that. So for 1041, what do you see as a sigma level in the table? Let's see who is paying attention typing here. For 1041.67, what is the sigma value that you are seeing? 4.47. So somewhere close to 4, between 4.4, actually 4.59 is more closer than to 1041. 4.47 is more closer. No, 4.59 is more closer. Sorry, 4.59 is much closer because it's 1000. That's 1500. Probably 4.58 or 57, something like that. Okay, interpolate. Absolutely. So calculating sigma value is very easy. How many of you feel it is super easy? Just type SE in the chat box. Yeah, this is a standard table. Okay. We will see some more examples also. Don't worry about that. Now we have seen around this area. So if you want to increase your capability from, the reason that I've circled it twice is here, okay? Now you are in this area of, let's say, 4.59. In case you wanted to, if you were, if 6 sigma, you have to understand that if sigma value decreases, the defects increases. Okay, the defect per million opportunity increases. That is something that you need to remember, because people get confused. The more is a sigma, the lesser is the defect. They're inversely proportional. Okay. So defects per unit, we have already said total number of defects found in the sample by sample size. For example, one more sample for understanding. Example for understanding. If you have 26 defects, 10 units of products produced, the DPU is, number of units is 10. So defects is 26. So 26 divided by 10 is 2.6 defects per unit. Okay, 26 divided by 10, 2.6. This is simple example. Okay. Now, which metric represents average number of defects observed per unit of output in a process? DPMO, DPU, PPM, and DPO. Simple, right? Defects per unit. And I'm asking questions so that it reinforces. These are the questions that will be asked in the exam. The correct answer is DPU. Okay. Now, example. Some example I just want to give you for you to rigorous. Let's see who is doing a quick, simple mathematics. Okay. 2 defects are there. And sample of 100, which means 100 units. With each 5 areas inspected. So that's called opportunity. Okay. 5 areas inspected is called opportunity. So my question is, how many opportunities are there? Total number of opportunities, how much? What is the total number of? 500 is the total number of opportunities. Opportunity is 5. The total number of opportunity is 500. Correct. And defect per opportunity. What is defects per opportunity? 2 divided by defects per unit. Defects per unit. 2 divided by. What is DPMO in this case? Defects per million opportunities. 2 divided by 500 into 10 power 6. If this is crystal clear, type CC in the chat box. You have to be crystal clear in all this. Okay. DPMO, number of opportunities in sample, 10 power 6. Okay. 4,000. So since we had 4,000, I picked up that from the table. We had picked up those numbers. So we can see from the table, you can see from the earlier table that we had, right? This table we had 4,000. 4,000 is how much sigma level? 4,000 is how much sigma level? That's why probably I put here. All right, just a moment. All right. So PPM stands for, very simple question, right? PPM stands for, of course, all of you will answer this question. Parts per million. Okay, this is no brainer. So parts per million is nothing but it's units. Okay, that's why DPU, defects per units, is there. PPM is typically used when the number of defective products produced is small, so that a more accurate measure of defective rate can be obtained than percentage defective. So internal PPM of the plant is calculated on a monthly basis by parts rejected or scrapped out of manufacturing parts. That's how the parts neither meeting specification, not rework. All that we know, I'm not going to read all this. So it is just manufacturing, magnifying the severity. Example we will see. The part manufactured, let's say in this time, so many pieces were manufactured and 681 was scrapped, okay, or rejected. So what is parts per million? Just you can put the number on the, type the number on the screen, that's enough. Yeah, that's right, simple, into 10 power 6, that's important, okay? See, defects per unit, that's why DPU is there, defects per unit. No, not defects, this is defectives, right? Rejected parts, defectives. Defects, number of parts that is rejected, percentage of parts is just into 100, and parts per million is into 10 power 6. Okay, so 1972 is a ppm. So difference between ppm and dpmo should be clear. Okay, the question is how ppm is calculated. Defective units divided by total units produced multiplied by 10 power 6. Defective unit divided by total multiplied by this total defects. So we have seen all this. This is one more last example. This is maybe you'll do for homework. 4,500 engineering applications. The audit shows that this application contains 300 defects and 12 key fields. Okay, these are all opportunities. So if you want to calculate, again, please, you can write in your notebook, defects per unit is 300 defects by total units, which is 4,500, and total number of opportunities is 12 key fields. So 4,500 into 54,000 total number of opportunities, defects per opportunity is this, and DPMO is this, and finally you get from the table, you need to see the sigma value, which is 4.04. Let me share with you the table. Okay, now in the table, if you see 5555, okay, let's see the DPMO, which we saw as 5555 with 1 sigma shift. Okay, with we have to see with 1.5 sigma shift. I'll explain to you later why it is, and you see that it is between these two. Okay, I wanted to just highlight these two. Okay, let me put thick border around this. It is between this 5555, so it is 4 to 4.1. Okay, it comes between this. Okay, it comes between this in this, and I'll explain to you while doing the process capability study why we should do with 1.5 sigma shift. Okay, if this is clear, type super clear in the chat box. And if you found today's session interesting, valuable, useful, fantastic, awesome, whatever that you felt, put it in the chat box. I'll draw inspiration from all your